Hello, here we are again. We must be up to video number 9. So the flipped classroom continues. Let's see what's on our plate today. I heard from the grapevine, from a very reliable source, that number 27 was a little troublesome. So I'm going to pick up there, and all I have to do tonight is to help you with your assignment. You made a little bit of progress today as we went through a couple more problems, and tomorrow we don't have anything to slow us down. We'll just be working full steam ahead and make a lot of progress. Those who don't finish tomorrow, hopefully you're in range to finish. I'll assign those for the weekend. So hopefully that works out. We'll adjust it if it doesn't. So onward, number 27. Check your work as I go along here and see how you did, how far you got on this one. We are only looking between 0 and 2 pi, and I notice my mathematical nose is sniffing it out right now, and I want to work all in the same function. So I see sine and cosecant, so immediately I want to switch something so that it's all the same. The easiest thing to do is to change cosecant into its reciprocal function, sine, like that. Alright, so now, again, the mathematical sense comes out, and I don't want any denominators, so I multiply by sine x. So how do you know to do that? It's just years of experience with equations, which you have had, and to solve them, it's difficult to do with any denominators. So you multiply through to get rid of them. So this sine x will be multiplied all the way through. And of course, if you do it on one side, you must do it on the other. So we have 2 sine squared of x, and this over here, these will cancel, leaving the 1 in the numerator there. And sine x times 0 is 0. So now we're in familiar territory. We can breathe easily and relax as we see where this is going. Moving the 1 over, dividing by 2, taking this square root. Okay, this is painful. Here we have the square root. It would create a plus or minus out here. But we have the square root of a negative number. So that tells us no solution. So maybe that was what was bothering you on number 27. So no solution is the solution. Alright, hopefully that will clear up your anxieties on number 27. Alright, let's sniff out the next one. I wasn't sure which ones would be helpful. So I will do number 59 looked like a challenging one. I know you didn't get near that one, but at least that's one more down. 59 is tan squared. How long have I blabbed here? Say 5 minutes. I'll do 5 more. Alright. Tan squared. I'll move this down. I'm not sure if it's in the video. It's number 59. Tan squared x minus 6 tan x plus 5 equals 0. Alright, so with that one, you can probably, again, sniff that one out. And you notice we can't factor out a tangent because 5 doesn't have a tangent. So we factor it the old FOIL way. And it looks like this. Whatever goes in the first position must multiply to give us tan squared. And then we have to think of 2 numbers that multiply to give us plus 5, yet add to give us a minus 6. So we have that combination. You'll recall that we have to have both of these values negative. Negative 5 times negative 1 is positive 5. Inner product minus 5. Outer product minus 1, which do add to minus 6. So we have successfully factored it. So we can set each of the factors equal to 0 and solve them separately. So tangent x minus 5 becomes tangent x equals 5, and tangent x, minus 1 becomes tangent x equals 1. Let's start here. It looks safer. So when we solve that one, where on the unit circle is the second coordinate divided by the first equal to 1? I know that that happens at pi over 4. And is there another place? On this one, we are also looking between 0 and 2 pi. I think I assigned that for number 59. Let me check. Yeah, no. Let me see. On the blue sheet. 59, 59, 59. It is between 0 and 2 pi. So we are going to look all around the circle, and we find that it happens again at 1/4 pi, 2/4 pi, 3/4 pi, 5/4 pi. I don't have my unit circle in front of me, so I have to kind of go through some mental gymnastics. So if we were sketching those, is that on the video? It is, barely. So pi over 4 is over here, and 5 pi over 4 is over here. And that's the only two that will meet that requirement. Let's hop over here to tangent x equals 5. I'll give myself some space to discuss this one. So I'll move it up. Tan x equals 5. It's not on the unit circle. So I'm going to have to use something else to help me figure out that. So I remember the sketch of tangent. Remember there was an asymptote at negative pi over 2, which is not in range. And there was an asymptote at pi over 2. And there was a snake up like that. Then, after that, 1/2 pi, 2/2 pi. Then 3/2 pi, which is still in range. There's an asymptote. And then 4/2 pi, which is 2 pi. This problem's, and there's a snake in here. So this problem is only going, I wish I had a different color, but it's only going to cover this area between 0 and 2 pi, in between my thumbs there. So is there any place where the tangent could possibly equal 5 in this little rectangle? Well, I see, say if I put in a 1 and a minus 1, that the function tangent does go past it, and it looks like it goes forever, always getting closer to the asymptote, always rising. So yes, somewhere it's going to equal 5. The question is, which value for x will cause the y value to be 5? So the only choice I have is my calculator. So I'm going to put in there. Do you know how to tease that out of your calculator? What value for tangent gives you 5? Make sure your mode is on radians, because this is a radian problem right here. There's no degree mark. So those in physics class are probably in degrees, so you need to switch back. Put it in radians, and you're going to hit the tan inverse button. So let's see what happens when you're in radians. Tan inverse, second tan, 5, enter. I got 1.37. So that's telling me at 1.37 the value is probably somewhere in here for x. I go up here and the value answer will be 5. Alright, so is there another one in this box that will also have tangent of the inverse, the tangent equal to 5? Excuse me a minute. Alright, so is there another value? Looking at this box, you will see that I didn't hit the right button here. I'm probably out of time. Let me finish this problem and I'll check. Tan inverse of 5 is 1.37. So 1.37 is here. So is there another place in this box where the tangent will equal 5? And it looks like it's over here. See how this is going to go up and hit 5 at some point as well. So how do I know what it is on my calculator? My Dumbo calculator only gives me one answer there. Well, this is where I have to use my brain, and I can see that 1.35 or 1.37 can help me get the next answer. So I know that this value is 1.37 for x. So there's going to be one over here that will do the same thing. It'll mirror it. So how far away is this one from this one? Well, it's the same distance as this function is from this function at any point, and that is pi. So if I take 1.37 and add pi to it, it will get me the same value, 5, on this snake, just like it did on that snake. All right, so that one was an extra thought one, so we end up with 1.37, 1.37 plus pi, and then if we went over to the next snake, you'll see that it's out of range. So we have this one, and these two. So, all right, hopefully that was helpful. I'd like to do one more, but I'm not sure because I didn't time this correctly. So I'm going to shut down this video. You could pick up on part 2.